So 9.3 is exponential functions. So an exponential function is a function of the form y equals a times b to the x, where a is your constant, b is your base, and x is your exponent. And then we do have a couple restrictions. A cannot equal 0, b has to be greater than 0, and b also cannot be equal to 1. And so example number 1, we're going to go ahead and graph the functions f of x equals 2 to the x and g of x equals 3 to the x on the same graph, and we're going to state the domain and the range. So we're going to go ahead and do x, and we'll do 2 to the x and 3 to the x. So for our points that we're going to be plugging in, let's just do -2, -1, 0, 1, and 2. So 2 to the -2, that is going to be, you want to plug that into your calculator, and it will say 0.25, and then 2 to the -1, plug that into your calculator, and I would say 0.5, and then 2 to the 0 power, well, we know that's 1. 2 to the 1 power, 2 to the first power is 2, and 2 to the second power is 4. Alright, then we'll do the next one. So 3 to the -2nd. So we're going to plug that into our calculator. And you're going to get 0.11, 3 to the -1, 0.33, 3 to the 0 is 1, 3 to the 1 is 3, 3 to this 3 squared is 9. Alright, so we're going to go ahead and graph that. And I'm going to go ahead and draw my x-axis down here. And then my y-axis straight down the middle. And then we'll go ahead and do our table. So 1, 2, 3. So let's go ahead and do 2x first. So the first point is -2, 0.25, so about there. -1, 1/2, about there. 0, 1, 1, 2. So 1, 2, and then 2, 4. So there's my first graph, which is 2x, and then we're going to go ahead and do 3 to the x. So the first point is -2.0, so a little bit below that one. And then -1, 0.3, so a little bit below that one. Then we have 0, 1. Then we have 1, 3, and 2, 9. Alright, so we could tell that the 3 to the x is a little bit steeper than the 2 to the x. So let's go ahead and do the domain for 3 to the x. So the domain, it's going to keep on going forever in the left and the right direction, so -infinity to infinity. And then our range, well, it's never going to go below the x-axis, so it's never going to be a negative y value. So our range will be from 0 to infinity. And then for 2 to the x, the domain is going to be from -infinity to infinity. And then the range, same thing. That blue line is never going to go underneath the y-axis or the x-axis. So it's going to start at 0 and go all the way to infinity. Alright, so let's graph a couple more. So now let's do a fraction. So we're going to start off with our values. So we're going to do -2, -1, 0, 1, and 2, and 1/2 to the x. So 1/2 to the -2, 1/2 to the -1, 1/2 to the 0, I know that's 1, 1/2 to the 1 is 1, and 1/2 squared is the same thing as saying 1/2 squared. Alright, then for the first two, I'm going to plug them into my calculator. So 1/2 raised to the -2 power, that's 4, and 1/2 raised to the -1 power, that is 2. So we're going to go ahead and graph that. Alright, and let's go ahead and graph this. So -2, 4, -1, 2, and then 0, 1, 1, 1, 1/2, and then 2, 1/4. So this is my graph, and my domain again is going to be from -infinity to infinity, and then my range, it's never going to go underneath the x-axis, so that's going to be from 0 to infinity. Alright, the next one is graphing an exponential function. So now we have y equals 3x plus 1. So what I'm going to do is I'm going to transfer from example 1 what we graphed for 3x, and then we're going to go ahead and shift that. Alright, so here is 3 to the x. I went ahead and graphed that from example number 1, and what we need to graph is 3 to the x plus 2. So the x plus 2, that's inside the function, and so we're going to be able to shift that 2 to the left. So 2 units left. So each one of these points, I'll move them 2 units left. And this would now be 3x plus 2. And so my domain, since I just shifted it to the left, it's still going to be -infinity to infinity. And our range, again, since I just shifted it left and right, the y values didn't change, so it's still from 0 to infinity. Now, something where the y values will change, which you will see that in Algebra 2, could be something like 3 to the x plus 2, where it is outside. Okay, so but we're only going to be doing transformations to the left and to the right with exponentials. Alright, and next we have solving. So in order to do our next section, we do need to know how to solve exponentials. So the goal is to make the bases the same. So 2 to the x equals 16. 2 is the base, and then I need to try to make 16 with a base of 2. So I know I could write 16 as 2 to the 4th. After you get the bases the same, you could set the exponents equal to each other. So x is equal to 4, and that would be our answer. Alright, so the next one, you have 9x and then 27x. So I could rewrite 27 as 3 to the 3rd power. Well, can I write 9 as a base of 3? yeah, I could rewrite 9 as 3 squared. So 3 squared, and then to the x equals 3x. So this is basically, this is the exponent is 2x, and now that we have the same base, you could set the exponents equal to each other. So 2x equals 3. Solve for x, so divide by 2. X equals 3 over 2, and that would be your answer. All right, the last one, we have 4 and 8. So I could rewrite 8 as 2 to the third, and I could rewrite 4 as 2 squared. So 2 squared times x plus 3 equals 2 to the 3x. So now the bases are the same because they're both 2, and we're going to set the exponents equal to each other. So 2x plus 3 equals 3x. Distribute the 2, and then isolate x. So I'm going to subtract 2x to the other side. And x is equal to 6. So that would be my answer.